Dear students, this is the circuit diagram of a half-wave rectifier with capacitive filter in the output. Before constructing, let's see the circuit diagram in live wire. This is the circuit diagram that we are connected for the half-wave rectifier previously, and we are adding one capacitor in the output. We were added a capacitor and make the capacitor value into 10 microfarad. And let's see the output waveform of this circuit. Nothing significant change in the output waveform from the half-wave rectifier waveform. And now we are changing the capacitor value into 100 microfarad. Let's see what will happen when the capacitor value is changed to 100 microfarad. Now the output waveform a little bit changed. Now the capacitor value is again raised to 1000 microfarad, and let's see the output. Now a significant change can appear in the output waveform. The capacitor is charged and discharged in the output waveform, and we are again changing the value of the capacitor. Now the capacitor value is 1000 microfarad and there is a significant change in the output. Now we get the output of a half-wave rectifier with the filter, a rippled waveform. The output is rippled because of the capacitor is charged during the positive half cycle, and in the negative half cycle is the capacitor is discharged through the load resistor. Because of in the negative half cycle there is no output in the half-wave rectifier. So at that time the capacitor will get discharged. And let's see what will happen if the capacitance value again increased. The capacitor value again increased and we noticed that the ripple output is reduced. Increasing the capacitance value will decrease the output ripple. Now the capacitor value is increased to 5000 microfarad and we got a low rippled output waveform. Let's see the physical connections.
So here we have to connect the circuit of half-wave rectifier into the breadboard. So I am adding a filter of capacitor 100 μF and we have the resistor of 1 kilo ohm and the diode of 1N4007. If you want, then we can use a multimeter as always. And this is the transformer. Here I am taking a 15 volt peak to peak voltage at the output, I mean the secondary of the transformer, right? So we're gonna make the circuit diagram on the breadboard. So let's see what happen if we add a filter across the load resistor in the half-wave rectifier. The intention of adding the filter here is to reduce the ripple factor as much as possible. That means if you add the capacitor value, or if you increase the capacitor value, you will get the minimum ripple voltage at the output. So we're gonna make the circuit diagram and we're gonna check what happens if a filter is added across the load resistance of half-wave rectifier. So here we have a transformer of 15 volt peak to peak. That means I'm getting a 15 volt at the secondary of the transformer. So I'm going to take one end of the transformer and the center tap connection. The connections are similar with the previous one, I mean the half-wave rectifier without filter. The only difference is here we adding a capacitor of 100 μF for filtering purpose. So let's see what happens if the filter is added. I'm connecting the one end of the secondary, not the center tap. One end of the secondary is with the positive terminal of the diode 1N4007, and the other end is connecting with the resistant. And we're taking 1 kilo ohm resistance, and the other end of the resistor is leave for the negative terminal, which is connected to the center tap. So after connecting this, we're gonna make sure that we are going to add the capacitor filter across the load resistor, and we are going to watch the waveform on the CRO. So this is the basic connection of a half-wave rectifier without filter. Across the load resistor, we are going to add the capacitor, right? I am going to connect the channel 1 for the input and channel 2 of the CRO for the output. So here are the connection. So let me add the capacitor across the load resistance. So if we put the CRO in dual mode, we can see the input and the output simultaneously. So here we go. So here we are. I'm going to add the capacitor of 100 μF. So let's see what's going to happen in the CRO. See, you can see the ripple voltage. This is the output ripple voltage. I am setting the voltage per division in 5 volt. Then put the CRO in a dual mode, then you can see the input and output simultaneously. See, there is no output at the negative half cycle of input. That means the capacitor is discharging at the negative half cycle. So from the CRO we have the value of Vm, which is equal to 9.5 volt, and you can also calculate the value of ripple voltage, that is equal to VRPP equal to 2.8 voltage. So that by the equation we can calculate the VRRMS value. The VRRMS equal to VRPP divided by 2√3. So let's calculate the VRRMS value. VRPP divided by 2√3, which is equal to 2.8 divided by 2√3. Right. So which is equal to 2.8 divided by 3.464, which gives the value of VRRMS, which is equal to 0.8082. Next we have to calculate the VDC. For the calculation of VDC, we have the equation VDC equal to Vm minus VRPP divided by 2. That is equal to 9.5 minus 2.8 divided by 2, which is equal to 9.5 minus 1.4 equal to 8.1. So the ripple factor equal to VRRMS divided by VDC. Right. So we are going to calculate the ripple factor, which is equal to 0.8082 divided by 8.1, which is equal to 0.099. So let's see the value of half wave rectifier